Okay, continuing on where we left off in the last video, we're right in the middle of Module 1, Lesson 2, Student Page D. So we had written two scenarios for each problem. This is equal to positive 5, this is equal to positive 5, this is equal to negative 5, this is equal to negative 5, and then we also wrote a arithmetic equation or a addition problem in order to symbolize what we have there, to show the operations for addition. And we'll learn in the next packet that when the signs are different in addition, you subtract and keep the sign of the larger. When the signs are different, you subtract 8 minus 3 is 5, and you keep the sign of the larger. So you'll be able to tie this all together. You'll be able to do it with a number line. You'll be able to do it with chips. You'll be able to do it using the rules. So if you forget one, you have a bunch of backup plans. Okay, so let's do one more together, and then you can shut off the video and try the next two on your own just to make sure you're doing okay. So 3 negative would be, or negative 3 would be 3 negative chips, the easiest descriptor of it. Or we could do, how about 6 negatives? 1, 2, 3, 4, 5, 6. And we need to only have 3 left, so that means we need to put 3 positives underneath because we want our answer to be negative 3. So ding, ding, ding. And there's our answer, a negative 3. And like the others, we can write an addition problem from it. So we started with 6 negatives. So negative 6 plus, then we added 3 positives. And we saw that when we had negative 6 and 3 positives, 3 of them canceled out and left 3 negatives. And again, we can use the rules that we're going to learn in the next section. When the signs are different, one's negative, one's positive, you subtract. 6 minus 3 is 3, and you always keep the sign of the larger number, which you can see is negative, just like the larger number here. Okay, so time for you to shut off the video and try the next two on your own. Okay, and then join back and we will compare answers. Okay, so on this first one we have positive 3. So I'm going to do the easiest way first, plus 3. And so we could do 3 positives, or no, let's do 6 let's do 7 positives. Let's kick up our heels a little bit. 3, 4, 5, 6, 7. So 7 positives. And I need only 3 of those positives left at the end. So that means when I go to put my negatives in, I can only have these 3 left. So it'd be negative, 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 because I need these 4 to cancel, so that my answer comes out positive 3. So we start with our first line, 1, 2, 3, 4, 5, 6, 7 positives, plus 1, 2, 3, 4 negatives, and that gave us positive 3. And again, you can see the rule in play. When the signs are different, positive 7, negative 4, we subtract. 7 minus 4 is 3, and we keep the sign of the larger, plus. Okay. And answers will vary, obviously, on that. Just make sure, you have them canceling and you're just 3 left. So you could definitely have a different answer than I do. It's not just one. Okay, last one, 0. Well, 0 can be done a lot of different ways. A million different ways, to be in fact a zillion, an infinite number of ways. You just need to have the same number of positive and negatives. So this would give me 0, and then we could increase it to, or change it to 4 positives and 4 negatives. And like I said, you could have a bunch of different answers for this. The key is that the number of positive and negatives have to be the same in order for you to get 0. Okay. So hopefully everybody understands that. And if we were writing an equation about that, we can do it about both. So this one we started with -2 and we added +2. -2 plus 2 is 0. And there's a rule for that. The rule is when you add opposites, you get 0. -2 and +2 are opposites. So when we add opposites, we get 0. And then this one would be -4. Nope, it was +4 first, wasn't it? 4 plus -4 is also 0, because once again we're adding opposites. A +4 and a -4 added together, we add opposites, we always get 0. Okay, and then I think there's some questions over here about this. So I'll keep that page handy so we can look at it. Keep it out of the pile for right now. So in part E, which is the one we just did, you wrote 0 in 2 different ways. Choose one of these ways. So let's choose the first way. So I'll put it up here so we can see it and see this at the same time. Oh, maybe we can. I might have it the screen a little bit too big, but at least we can see the first part of it. So choose one of these ways. We did. We're going to choose this one. Suppose the yellow or positive chips represents Jack's weight in week 1. So it looks like he gained 2 pounds. So I'll use the colors +2. So the yellow chips represent his weight in week 1. The yellow chips, there's 2 positives, so that means he gained 2 pounds in week 1. Represents Jack's change in weight in week 2 as a sign number. So week 2, it says red or negative chips represent his weight in the 2nd week. So that means week 2, he would have 1, 2 negatives. Okay, so week 1, we're supposed to use the positive chips in our first scenario. Week 2, the negative chips. Then it says, what is the combined change in weight over these 2 weeks? And that's what we were just talking about. So I love this problem because it leads into follows up on what we were just talking about. If we take the 2 numbers, 2 plus -2, we can see the combined weight change is 0 because he went up 2 pounds. So let's say he started at 180. So he went to 182 and then he lost 2 pounds the next week. He's back at 180. So that means a weight change of 0 pounds. What operation did we use to combine these? Addition. It's called addition of sign numbers. And the rule is when the signs are different, which they are, one's positive, one's negative, then we subtract. 2 minus 2 is 0, and keep the sign of the larger, which in this case 0 doesn't have a sign. Write a symbolical mathematical expression. Oh, I guess I already did that. So there's the mathematical expression. I think this one they just wanted 0 on there. That's okay. Same thing twice. Okay, so that's just another way of showing you when we add opposites, we get 0. Because they cancel each other out just like the positive and negative chips do. Okay, so next we're going on to number lines. Let me get my papers back in order here. To me, this is a great way too. I love chips and I love number lines. They're both really good ways to visualize your answers. So plot the given numbers on the number line, determine which number is greater, and insert the correct symbol. Because remember how I said keep the sign of the larger, so we have to know the correct symbol. So they're either going to be greater than, less than, or equal to. And what you do need to remember is how to read these, and there's a really easy way. When it looks like an L, so this looks like an L just tipped forward a little bit, that's read less than. L, less than. When it's a backwards L, that's greater than. So this is greater than, less than, or equal to. And whenever you're doing it to a number, the symbol always eats the big one. Most students I know when I teach 081 say, oh yeah, I remember that, eat the big one. So that's a good way to remember which direction to put the symbol. So here we have -5 and it says plot. Remember that means make a point, don't circle it. And +3. Write the number that is further to the right. So whichever number is further to the right is always going to be your greatest number. And students will go, oh, I get that. Positive numbers are always bigger than negative numbers. But what if they're both negative? That's why you need to know this rule. Whichever number is further to the right on the number line, that will always be the largest number. So even when they're both in the negatives, -10 and -6. -6 is further to the right, so it's larger than -10. So write the number that's further to the right, 3. Insert the correct inequality symbols. It always eats the big ones, so it doesn't matter which order they put the numbers. You just always make sure it's eating the big one, eating the big one. So this would be read -5 is less than 3. This would be read 3 is greater than -5. Okay, so there's 2 more of these, right? Yep, so let's go ahead and do one more and then you guys can do number 3. So -4, -7. This is when you really need to know that rule. So -4 and -7. Write the number that is further to the right, -4, so I know that means it's the largest. And it's just the opposite of when they're positive. When they're positive, 7 would be largest. But when they're negative, it's the opposite. But I just always remember which number's furthest to the right on the number line. So -4 is larger, so it eats the big one, eats the big one. Oh, and this is plot any 2 numbers. So let's pick 0 and -5. Okay, so you guys go ahead and do that one and then write your 2 inequality statements. Okay. Okay, so plot 0, plot -5. Which number's furthest to the right? 0. So that means 0 is larger than -5. So that's read 0 greater than -5. It eats the big one. Or you could flip it around and say -5. Now it looks like an L, less than 0. And again, it's eating the big one. Okay, so super easy way to keep those apart. So I'll have students in my high level classes go, well, I don't really know the difference between greater than and less than. Less than starts with an L, so pick the symbol that looks like a compressed L. L for less than. That's how I do it every single time. My brain goes, oh, that one looks like L. That's the less than. Okay, so I hope everybody did okay on that one. Okay, I guess we just have one page left. just make sure. Sometimes I get going and I skip pages. I don't think we skipped anything. Nope. So we're on our last 2 pages here. So into student page E. In the space below, write an inequality statement with these 2 numbers using the less than symbol. Oh, didn't I already do that? What did this ask me to do? Oh, okay. They only wanted 1 for each. Using the greater than symbol, so I should have only put this one here. And then they wanted the less than symbol on the next one. So -5 is less than 0 goes on the next page. I should have read my directions a little more carefully. So now write it using the less than symbol. -5 is less than 0 because 0 is on the right. Fill in the blank with a single word that makes a sentence true. If 2 numbers are positive, the one that, oh, I hate this. Never mind, don't even read that. Because that gets students so confused because they're like, oh, it's farther from 0. No, 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 no. Always look for the number on the right. So don't even look at that. Whoever made this was crazy. Okay, so not anything you ever want to know about which one's further, which one's closer. No, no, no. Too confusing. Just remember the number on the right is always the largest. Okay, last page. Okay, so write the given number of mathematical expressions using correct language. And I love this to be the ending of this lesson because it helps students with the language. Like I said, a lot of students haven't heard of the word opposite. So that's good for us to practice. Negative, I think most of you would know that's -6 and that this is +8. Everybody knows that. But sometimes students don't understand the difference between negative and minus. So negative is just a number in front or a symbol in front of a number. Minus is when it's in between 2 numbers. So this would be 3 minus -4. And so that's the difference between minus and a negative. Okay, so we have in words, this would just be -6. And when I'm teaching this in person, which I do every spring, students will ask me, could you say the opposite of 6? Sure. A negative can always be used, or the word opposite can always be used in a negative, but here it's not optional. You have to say opposite of -6. You can't say -6. So yes, that could be read opposite, but we usually don't say that with a number. Now, when it's a letter, we do. Here we would say the opposite of A, because we don't know if A is positive or negative, so we can't say -A. But when it's a number, we can say -6. And so this would be the opposite of -6. And does everybody remember what that's equal to? So I like to do that little review as we go through on this. Remember, double negative, always a positive. So ding, make that a big plus so we know the opposite of -6 is really 6. And that's not part of what this said, but I'm just practicing and reminding you of some things we learned in this lesson. Okay, so I think everybody knows this. Because it's a positive, and they put the plus sign there, like in chemistry, when it has a positive charge, they put the plus sign. So when you see a positive, you really should state it. So this would be +8, where the next one would just be 8. So usually that's when we're talking about electricity, working in chemistry, that they put the positive in front. So if it's there, you should read it because it's probably there for a reason. In math, not so much. You won't see that so much with the positive in front. If it's a positive 8, it's just assumed like this. But there are a lot of applications that need that in front of it. Okay, next we have a negative out in front. Remember, we can't say negative when it's out in front like that. We say the opposite of positive 8. So the opposite of positive 8. Or you could even say the opposite of 8. I'm just going to state the positive since it's in there. And do you all know what that answer would be? The opposite of positive 8 is negative 8. So this next one has an addition sign. So of course we're going to say plus on that one. So that would be 3 plus 8. And I think everybody knows that's 11, right? And let's do one more and then you guys can try a couple on your own. So this would be negative 3. Yes, you could say opposite of 3, but usually, like I said, when it's just in front of a single number, we just say negative 3. So negative 3 plus 2. And this gives you a chance to practice your chips. I have 3 negative chips and it says plus 2, so that means plus 2 positive chips, right? So 3 negative chips added to 2 positive chips. This one cancels with this one. This one cancels with this one, so I know the answer to this problem is negative 1 because of the chips above. So every time I see sign numbers, that's what goes through my head. Oh, make chips. 3 negative chips, 2 positive chips, 2 of them cancel. I have 1 negative chip left. Okay, so you don't need to do the summary here, because we're going to summarize a lot in the next packet. So just go ahead and do those 2. Stop the video for a few moments, write them in words, and then also see if you can give me the answer. I think you should be able to give me the answer on both of them. Okay? So take a moment to do that on your own and then come back and we'll check your work. Okay, so do you remember earlier in the video when I said the minute you see double negative, you should not do another step until you make it plus. And that applies here as well. Double negative, you immediately make it positive. Anytime you see 2 negatives side by side. So what this turns into is just 3 plus 4. So when we go to get the answer, we can see it's 7. But I should have written the words before I did that double negative thing because they want the words for the original problem. So that would be 3 minus negative 4. So 3 minus negative 4. Oh dear, wasn't this the one on the last video or 2 videos ago? I said, oh, I need to throw this one out. Of course, I put it right back in the box. So 3 minus negative 4 is really 3 plus 4, and that would give me an answer of 7 if I were to work it out. And it didn't ask for that. I'm just reworking our rules that we learned in the video. This is what they want, 3 minus negative 4. Okay, now this one we have a negative sitting outside parentheses, And when the negative is sitting outside parentheses, that's when we call it opposite. So this would be the opposite, and parentheses are called a quantity. So we'd say the opposite of the quantity 4 minus 2, or the opposite of the difference of 4 and 2. So that's how we would say that. The opposite of, and you could put comma, 4 minus 2. You just have to let the reader know that it's not just the opposite of 4. So you need a comma, or you need to say the word quantity, or you need to say the word difference. So I'm going to say the opposite of, oh, and this is the other one that I said to throw away. And then see how I put the comma? So that means everything after the comma I'm doing the opposite of. 4 minus 2. So if I didn't have the comma there, that would mean the opposite of 4. So this would mean negative 4 minus 2, and that's not what this is. So that's why we need the comma, or to say the opposite of the quantity, but the comma takes the place of those words. So opposite of this. So 4 minus 2 we must do first because it's in parentheses, and then we move the negative up in front, and we can see that's 2. So 4 minus 2 is 2. The opposite of 2 is negative 2. But without the comma or saying the quantity, this would be wrong. Because without some note, if you wrote it without the comma, it would just mean opposite of 4. And this means the opposite of the answer of 4 minus 2, not just the opposite of 4. So that's why the comma must be there, to show that first do this, then do the opposite. Because these two things are very different. This one we just learned the answer's negative 2. This one the answer's negative 6. So you leave the comma off, it means the second one. You put the comma in, it means the first one. So that's why we have to put that comma there to show that it's the opposite of that whole thing. Okay, that is it for lesson 2. So 2 lessons down. So I'll see you in the next lesson. Bye.